What did you do to the microphone to fix it?
I don't know. I think that this is on mute. It was on mute.
Oh.
There's a button. Javier, well, which is a good idea because it buzzes a little bit.
Is it still buzzing?
A little bit, not as bad.
So do you think it was because it was on mute that was causing it?
No, so that's different.
What's changed now?
Nothing.
Oh, okay. Nothing.
The weather
So they got 3 people?
plus you. Should be good. That's Jerry's.
48 lemon. Before the winter of the first one,
Oh, yeah, should be. Well, there should be. Oh, yeah, maybe I'm on the wrong screen, Chuck.
Oh, I haven't plugged it in yet, so you shouldn't be getting anything. Chuck, you know what you're doing? Yep. Okay, now we're plugged. We should.
The microphone's very sensitive.
where all
Okay, we're in business.
clothes.
Should we turn up the lights?
Yeah. Well,
Do you want the lights up back here, Chuck?
No, that's fine.
Please.
Oh, okay. Doesn't matter. I did it one night there, yes, but this isn't one of those evenings because that was a miss. Okay, so asteroid occultations. This is something I just got into in the last 2 years, really mainly for the last year, and kind of fun. And of course, I didn't do all the pictures, so these people are to blame. And so people have been sort of interested in asteroids for the last year or so, since the February event in Chelyabinsk. And
Is that a real photo?
most of it.
No, I
Yeah, real signs in Russian. And so now, now there's all this talk about a planetary defense system, and you get the B612 Foundation out raising money to get a satellite that's got a scope that's going to look outward from us so that we can see stuff that normally we wouldn't see because it's behind the sun, things like that. And, the dinosaurs, for example, didn't fund a space defense program. You can see that. So anyway, I've always, this is one thing I heard about many years ago and I've always been sort of interested in. And, if you want to find new asteroids or you want to look at near-Earth asteroids, most of those are small things. You need a big fancy CCD camera, you need a big telescope. But mainly for a lot of those things, you need to be persistent. You need to just be looking every night, so it's made up for automated systems. And so I wasn't really big into that. I wanted something that I could do in between outreaches. And so the nice thing about the main asteroids is you got lots of them. I think we're tracking 600,000 or something like that now. And so mainly out between Mars and Jupiter, you got some Trojan asteroids in the orbit of Jupiter, and occasionally get the Earth crossers coming in.
never heard of that.
Trojan asteroids sit in the Lagrangian points where the gravity cancels out of Jupiter, and it looks like a couple of other planets now. They found one, I think, for Uranus, and occasionally the Earth gets one, temporarily at least, that comes in. And they're at the 60-degree points, apparently, where things cancel out dynamically. So there's a couple of hundred, I think 700 Trojans. One side is, one side gets the Trojans, the other side gets the Greeks. I think they're called Ajaxes or something.
oh, that's cool.
So some of these are big enough that I can see them with a small telescope and not a very fancy camera. So I had heard about this before. There's this group called the International Occultation Timing Association, and they do, or IOTA, and they do. They started out doing lunar occultation stuff, where they would watch stars as they passed behind the moon, And they would both detect close binary systems that way, or they would go to the greatest points along the moon's shadow, where you could see multiple appearance and disappearance events as the asteroid or star, whatever, this is stars, went behind mountains on the moon. And so they were mapping the terrain on the moon pre-Apollo. Now I think that's kind of, I'm not into that. I think that would be kind of fun to do, but not really contributing anything, because you've got laser altimeters in orbit around the moon now that are mapping it down to millimeters, So people still do that, and it's kind of fun, I guess, to plan to go and catch where you're going to get the most blinks of the star per mountain range. But one of the other things that they started doing was asteroid occultations. And so what you have is all these hunks of junk floating around there, and because there's a lot of them, every once in a while, they kind of look like ducks. And every once in a while, they pass in front of a star. And so the idea is you get out and catch these events. And so about 2 years ago, I tried 2 of them in a year. Didn't get anything, and one of the things you could do is you could just watch in a telescope, if your telescope could reach the brightness of the star, and have a tape recorder and WWV playing in the background with the time signals, and then you just holler out, disappear, reappear, or whatever like that. You can do it with very simple equipment. But then you have to go through sort of a calibration phase where you figure out what your reaction time is to seeing something happen. They actually have web applications you can go and measure your reaction time for doing it. And that seemed kind of tedious to me. So, but then I looked on their webpage, the IOTA webpage, and saw that one of the cameras they use for doing this kind of stuff on video was really one that I already had, which was a Stellacam 2, which is a black and white video cam that is pretty sensitive, that I had already gotten for outreach about 10 years ago. And that is used to videotape these events. And also you can get a video time inserter that is a little GPS box, $250 or so, that talks to GPS satellites and puts your precise location in your timing. And so it takes the whole reaction time out of the equation. All you've got to know is for the different cameras, have they been characterized as to what frame they put the image up, or how long the delay is between when an image actually hits the sensor and it actually gets output onto the tape. And they have that pre-calibrated for a bunch of cameras. And so I tried a couple, and I really started that around October or so of last year. And then in December, there was a near-Earth asteroid that came by, and I happened to see it on spaceweather.com. It was going to pass, 6/10 the lunar distance away, be gettable by my camera, which can go down to magnitude 13, and it was basically going to pass right overhead Santa Barbara. And that was on Saturday it was discovered, on Sunday it went up on spaceweather.com, and on Monday night I went out and I videotaped it and caught it going by, and I thought, okay, that's kind of fun. So now I wanted to do this with the Asteroid Occultations, and I tried 4, didn't get anything, and then number 5 was this one, Tergeste, in January of this year. And you can see we're kind of on the edge right there, right on the edge of the shadow. This is the predicted width of the shadow as it hits the Earth. Here's the sort of the error ellipse, and here's the error bars, the first sigma or whatever. And this is the kind of the size of the predicted size of the shadow and the orientation they think it might be in as it passes over. There's a little picture of a star field. The IOTA webpage has these predictions, and you can go look for an area where you live. And when you join IOTA, they actually send you these gigantic files showing you all the possible asteroid occultations for your location, plus or minus either 300 kilometers or 10 sigmas, because they want people to look even when they're outside of the path, because they have discovered moons going around asteroids that way, where they get secondary occultations. Or if their prediction for the asteroid just isn't very well known, they can nail down the orbit of the asteroid. So the whole idea is you nail down the orbits of these asteroids a little bit better and figure out just exactly where they're going. These usually aren't, I can't do like OPT did last year for their sale and say, tell everybody you're working on planetary defense, buy these cameras and do this. And can't really say you're doing that for this, but it's just kind of a fun thing to do, because it's really like, hunting down fake little galaxies to find a star that's going to get occulted. Plus it contributes a little bit, what the heck. So that was Tergeste. Here was the little, you get these finder charts at various scales. The first one shows the constellation it's in, and then, there's like a 10 degree, and a 5 degree, and a 2 degree, and a 30 arc second view. This is a 30 arc second view for the star that was going to be occulted. And so you go get that on your little, I just do it on my laptop, get the display from the camera, and have a capture device. and match the star field. And there's also a really great service on the web you can do that I'll talk about at the end to verify that you're on the right star, and then you videotape it. And you've got to have basically nothing going on in the background of your computer because you don't want to drop frames, which would mess up the timing. So you kind of turn off all your SETI at home stuff that's going on and suck down the video and record it. Or you can put it on a VCR. A lot of people use just little camcorders. There's a certain set of camcorders that are favored that are out of production now, but apparently they're floating around on eBay. And they can be remotely triggered. So you can put them with a little remote that says, start me at 7 p.m. And people leave unattended scopes spaced along the path of these asteroid tracks and have them automatically turn on and look at what's going. And it really helps to have a good go-to scope to go to the area, but you don't need that. You can do it even with an undriven scope because along with these predictions and these maps, they put up what are called pre-point stars. Stars that for different time intervals, if you center that star in your telescope and then just leave it and let the Earth rotate, the target star is going to rotate into your field of view by the time of the occultation. So somebody does all these calculations and publishes up there. You can get it. You can just go pre-point a scope and walk away from it and hope nobody steals it. So here was the January one for Tergeste. And so, first you put up a minute or so of your latitude and longitude in case somebody wants to ICV in my driveway. And then you start videotaping the star. Now this one isn't a full wink out because it turns out the asteroid had enough magnitude that it could still show even when the star got hit. But right about, in about 3 or 4 seconds here, you watch that guy, there you go. So, it's way down for a few seconds. And then pops back up. And it wasn't instantaneous because I had to integrate to get to that depth. So this was like doing a frame every 4 seconds or something, or four frames a second. So it wasn't as good a timing as you could possibly get, but you can still get the event. And then, why is that starting again? And then you can send off your data, or there's free programs that run under Windows. I refuse to give Bill Gates any money, so I just send it off to the guys in IOTA. But here's the analysis of that event. It was pretty detectable, good signal-to-noise ratio. And here was the path. This is the center line, this is the predicted shadow, and this is the error bars. There were a bunch of other people that set up, but I was the only one that got it. So basically, it got about 0. I mean, that's just rolling the dice, right? But that got basically 0 amount of information. All it told them was that it passed, here's the predicted path and the predicted time. So it was just a little bit late, and it was a little bit north of where it should be. And from estimates of the size of the asteroid based on an estimated albedo, that was the size they thought it would be, and it looks like, I caught kind of the edge of it. So it's not really giving you a lot of information, although it's confirming that, the asteroid's not a lot bigger than they think, and dimmer, and things like that. And then these are the tracks of the other.
So it does tell you the size of the asteroid.
It tells you a little bit about the size, yeah. It's at least that big, right, to do that at the speed it was going across, which was something like, 11 kilometers per second. So zoom in by. So then there was another one. I tried 4 more, didn't get anything. And then I got, on try number 5 again, I got another one. This is another one. This was passing a little bit north of us in March. Hugo was the name of it. And this one was much shorter duration, but the video is much, much longer. So let me cut down on the pain here and go out to, I think it was about 6:35. Let's just start that. So this time it's this star here. I didn't center it too well because I didn't verify that it was. There we go. See, okay, so that one was a blink and you'll miss it type thing.
And why is that shorter? Is it smaller?
It's a smaller asteroid and moving faster. So bing, bing. Okay, so basically it was only 30 frames or so that was in. And that was why I didn't bother centering it, because I didn't verify it was on the target star until the last minute. I just said, as long as it's in the field of view, it's good. You can see how many hot pixels are in the camera. All these things that look like little lines, those are hot pixels. There's a dead line here. And when you go up to higher integrations, that stuff just gets all snowy and there's a lot of noise. So if you want to have a nice picture of it, you got to do all kinds of dark frames and stuff. But just for doing this, as long as you keep the event from happening on one of your hot pixels, you're okay. All right, we've seen enough of that. So this one was south of the target line, you know, and here's where it was predicted to happen. There was one other person closer to the center line in New Mexico that tried to get it, but didn't. And then big. So this didn't provide a lot of information to anybody, just that it sort of jives with their predictions, other than the fine location in its orbit. What's really cool, which hasn't happened with me yet, is when you get lots and lots and lots of people doing it, and you get lots and lots of chords through the asteroid. Because then you can really start to map the shape and find out all kinds of interesting things, including, there was a big surprise, okay? This one was predicted to be a single asteroid that was this big in extent, and they found out it was a binary when they mapped everything. That was before my time. This is like 2009. But I mean, just fun stuff like that, where for me, it's just fun and relaxing to go find a star and, you know, videotape it for a couple of seconds, but it also contributes something to finding out about the universe.
Did you say these are in the asteroid belt or not in the asteroid belt?
Most of these are main belt asteroids. Some of them are high inclination, weird orbits. And this one, that was the big one that everybody was excited about all year, is a known binary Trojan asteroid in one of those Lagrangian points for Jupiter. Patroclus, I think is how it's pronounced, okay? It's about 80 miles across. And at first, the first predictions were that it was going to pass about here. It was shifted down a bit, and that we were going to be very close to the main shadow path for just the center of mass of the system. And they had no idea how these two were in their relative little orbits of their own. And so I thought, okay, great, I'm going to go for that one. They've been campaigning for people to sign up to look at this one all year long because they wanted to get some information out of it. And then right before it happened, like a week before, they found some adaptive optics data that like Canada France Hawaii telescope had done, showing the binary asteroid, and they thought they could get the phase of the orbit where they were together. And so they revised the prediction. This is where Patroclus was predicted to go, which I thought, oh, bummer. But its companion is called Venetius. And Venetius is just about as big, a little tiny bit smaller, and was going to come right over us, pretty much. You know, so I thought, oh boy, cool. So I went out and I set up in the driveway, and I found the target star, and I verified I was on it. And half an hour before the event, the marine layer came. Yeah. So that told me that if it's really something I want to do, I should go up to the gun club. But even though I didn't get any data, and they put me in here, even though I just had a cloud out. I wouldn't have seen it anyway because apparently they got the phase just about 90 degrees out, and so they were going in trail, and so some left decks that were along this part of the path near the predicted center line got both. They got two occultations for the price of one, and here they were able to map the components. And you know, since then I've had since the two pluses I got, I've had 18 straight misses in a row. But, yeah. But the way to look at it is you're part of the picket fence, right? You're just one of the pickets in the fence, and maybe you get it, maybe you don't. So this is all the junk that you need in addition to a telescope.
And a marimba?
In a marimba, yeah. You need those little fuzzy things to really do it right. And so here's the camera. It's just the Stellacam 2. It's a modified surveillance, black and white surveillance camera. And the neat thing about it, it has a remote control. So that you can plug it into the telescope, but you can control the settings on the camera with this little hand paddle. And not have to go up and bang around the telescope and lose your target. You know, video cable to take that into the VTI box. Here's the VTI box that does the GPS. It inserts the time into your video stream. And so there's another cable to go from that to the capture device that plugs into your laptop. Here's the control panel for the drive on the telescope. This is worth its weight in gold. This is like a $10 item. This is a little plastic Botnov focusing mask. So you can make sure your scope's in good focus, and that really gets you like a magnitude more of stuff that you can see on the video when you tease it down into the noise. So that's really worth it. Plus, when you take an astrophoto and forget to take that off your telescope, you get really neat spikes.
Chuck, of those two, which one? How big was the largest? Did you say?
The largest what?
How big was the largest asteroid that you photographed?
The physical size, I think one of them was 200 kilometers, so 120 miles across.
And they're at the asteroid belt or Trojan
Yeah.
and Jupiter.
Yes.
That's pretty big to occult a star from that far away.
It's pretty, it was amazing to me how many of, I thought, oh, what's the chance, right? That something's going to go in front of a star from my point of view. I might get one of these events a year. And really, if you look at one that goes like right over my driveway, yeah, it's like 1 or 2 a year. But when you look at the number that are potential that could happen and where you're in the error bars, it's like, there are 21 of them for December for my house, that they want you to do. They're 300 kilometers or 10 sigmas. There's one tonight at 10:12 that I'm not going to do. But it's not a very likely one. And so here's all the information you can get from their webpage. It has all the fine RA and DEC and stuff that you can type in, or you could get the pre-point stars and stuff. So that's it all just laid out, and then here it is in operation with the video being captured out of focus and the GPS information going up, and of course the beverage keep you awake.
No, cool.
Yeah. And this was the Patroclus event. This was the October Patroclus event when I set this up and took the pictures. I set up way in advance because this was, oh boy, this is when I really want to participate in it. Shortly after this is when the clouds came in. And so another really neat feature you can get is you can take a snapshot of your video screen that's there. And I actually did a dark frame to get rid of the hot pixels that are in here, so those are gone. And you submit this, and since I'm sitting in my driveway, I have Wi-Fi access, right? And you submit this image, and they don't really care what the image scale is, they don't care what the rotation is, they don't care what the flip is. You submit this to astrometry.net. And it helps. You can say, okay, I'm near these RA and DEC coordinates. So here actually, this is Washingtonia. This was in November sometime. Here's the star, here's the asteroid approaching it. And they ended up merging, and it looked like one bright thing, and then separating apart. So I never saw the actual event. It kind of merged with the image of the star and came out, but the full thing never dimmed down. So I didn't actually get an occultation. But you submit this image to astrometry.net, and it comes back and it tells you, okay, here's the field you're looking at. Within about 10 minutes, even if you haven't specified anything about where it is, which is just amazing to me. So I can verify that I'm on the right target, even though I've matched all these little patterns and stuff. That told me that, yeah, okay, here's the asteroid and here's the star.
So in many cases, the asteroid itself is luminous.
In fact, for the one tonight, the asteroid is brighter than the star. So they're going to merge, and the whole thing will get brighter than both of them. And then if they happen to cult, then it would dim down just a tiny bit and then pop back up. And so these are the places. Occultations.org is IOTA. If you go to iota.org, it's some other weird thing. Asteroidoccultation.com is where you can go to get all the predictions for the year, and some even farther in advance. Not only including asteroids, but now they're giving predictions for Kuiper belt objects. And I haven't tried any of those yet because so far the stars they've been occulting have been too dim for me to reach with my scope. I'm just using the 5-inch, so I can go down to magnitude 13. And then pointsource.com, this is Derek Wright's site, and you can go there and get Google Maps, right down to the street level where the asteroid shadow is going to pass over, and that's where you get the pre-point stars, and you can get the odds that you're going to see it for your location. I stopped looking at those because they're always so low, but it's sort of the Las Vegas version of these other predictions. And then nova.astrometry.net is where you can go to submit the photographs, GIF or PNG. They want something that's not JPEG, and then come back and tell you where you're pointing. So that's it.
Chuck, do they do this for binary stars and things?
Well, in this case, where you can see the occultation, sometimes the stars are binary, and you can get, if they're really close binary that you can't break apart telescopically, you can get information about their position angle and stuff from the occultation.
Thank you.
But their main goal is really the asteroid positions.
Yeah, I know there's a path there, in there, but do they give you a confidence level, like 5%, 10%, that it's going to fall where they think it will?
Yes, that's on the point source site is where you can get a 32% chance or 5% chance, 6% chance. And I've stopped looking at that because, what the heck, if it's close, I'm going to try for it. And actually, if it's far away and there's like 0 chance you get something and you get something, that's when you've actually really contributed something. So I figure, what the heck, just I'm gonna shoot for a whole bunch of, that's why I'm trying to do 20 of them this week.
You get that info on the track from NASA?
They get the information.
Observatories all over the world.
Observatories all over the world. They take high resolution updates from Minor Planet, MPC, Minor Planet Center in Harvard, and from Flagstaff Observatory, whoever they are, Lowell Observatory. And every day they put out a latest ephemeris for for like 60,000 asteroids. And so you can download the latest data. Programs like XFM and Starry Night Pro can suck it down. I use XFM, so I'm not sure Starry Night Pro can, but I'm pretty sure it can. And then you can actually go, I've actually started generating my own finder maps where I have a rectangle that shows exactly the field of view of my video cam. So that way I can know exactly how to position some of those other asterisms and things to get the targets that are right in the center. So I've gotten better at that.
Any final questions? We got another couple more presentations to do.
Where do you get those bat mouth filters from?
Amazon.
I got it off OPT,
OPT?
but it's another company that they get it from.
Okay.
And it was $15 for one that would work on apertures from 3 to 8 inches or something like, or 3 to 6 inches. And I have 5 inch, so I can use it on Patscope, I can use it on my scope.
Cool.
Yeah, my 5 to 8 was like $19 on Amazon.
All right.
Yeah,
In
20
my
bucks.
own, what you do is to take U-graph stock and put it in your laser printer and print it.
Then cut it
You
up.
got it.
Cut that, yeah.
And on my 5-inch scope, 6-inch irrigation pipe, exactly, very well fits the front, a little bit slop, so I can have 3 sets forward in.
I tried doing one of my own that I printed out, but I tried doing it with like poster paper, big mistake. Because it's hard to cut nicely. And stuff like Kydex or some kind of plastic stuff works really well, but yeah, the transparencies are probably the right kind of plastic to work well.
Partially.
Any last comments or?
You see right here.
ISON's dead.
Okay. Our next presentation will be with Jerry Wilson doing the 2013 Advanced Imaging Conference, as it says up there. Thanks again, Chuck. That was great.